Hello, my name is Mark Adams, and this is episode 70 of Marksmess podcast, where I look at the world of geekery, usually with my daughters, and sometimes, like today, with a guest. This time we have Aine McKendry, who has a particular interest in creepy crawlology. Is that a good way of putting it?
That's a great way of putting it.
That's good. Exploring the universe of science fiction can have hazardous repercussions, not least as one of alien parasites. Whether it's being implanted with an embryo by a facehugger, being mind-controlled by Starro, or having your brains munched through your ears by an eel while exploring Ceti Alpha Prime. But that is just fiction, right? Maybe? We're going to look at that. Very nice to have you on the podcast.
Thank you.
I think this is your first ever podcast you've ever done.
First ever. Hopefully not my last.
Well, yeah, probably not.
Yeah.
But we know each other because we work in the same place at Giants Causeway. You've been doing sort of summer student work and helping out. And I think we've been there about the same time.
I think you've been there slightly longer, but in and around, yeah.
Yeah, in and around the same time. And you are, just to give context for the podcast, you're the same age as Charlotte.
I am.
And by the way, for the listeners, Charlotte just graduated, so we're just back last night from a graduation in England. Now, we're going to be talking about the creepy crawlies and the bugs and things like that. When did a nice person like you get into things like that?
It's actually a weird story. I didn't know about parasites when I was doing my A-levels. We didn't really cover them in the curriculum. The first time I learnt about parasites was in my first year of university. So I done biological sciences. So that's why I was introduced to parasites. And what made me fall in love with them is just how impressive. We think as humans we're the top of our game. We are the most evolved. And you have these tiny, tiny, microscopic, sometimes, beings that can exploit us, that can live in us undetected, use our resources for their own benefit, and we've no idea they're there. We've no idea how to treat them. We can't treat them. They evade our immune system. They are on top of the game, and we know nothing about them. So that's why I love them. Just in case anybody is still listening after that, and you now know what we're going to be talking about, the parasites, the creepy crawlies, including wasps. One has just come in here. Well, if you two are okay with a wasp, I'll be okay with a wasp. I'm okay with a wasp.
If you do find it and you want to stamp on it, that's okay with me.
We need them for pollination. Please don't stamp on wasps.
Don't kill wasps.
Don't kill wasps.
The
bees are going extinct. They're our next best hope.
So wasps actually do good.
Yeah, they do good. They are stingers, I know that, but
yeah.
If the bees go extinct, we have our last hope in the wasps for pollination.
Now, you saw my front garden and they're coming in. What I've done the past years is keep it long.
Great idea.
But this year I decided to go a wee bit mad, and I mowed, basically I mowed paths. I made a maze, let's face it, I made a maze. Julie's a wee bit incredulous about what happened. And we've actually found that the birds love the maze bit, because the garden birds are evolved to really like short grass.
Yes.
And they will pick through short grass, so they will hop about the grass.
Doing your maze.
And whereas the insects still have the long grass. Anyway, that's just a wee bit by the way. So we're going to be talking about different creepies.
Different parasites.
But they've got superpowers.
They do.
Right. I'm all in for this.
You're all in for this.
What are we going to talk about? What's the first one?
So, first of all, I just want to start with a definition so everyone knows what we're talking about. A parasite is an organism that lives in or on a host at the detriment of the host, but for its own benefit. So it's not like predation, where one organism kills another. The parasite wants its host to stay alive, and that's why they have adapted these superpowers to be able to evade our immune system, to be able to attack us, but we'll never know about them. We can't prevent we can take measures to prevent them, but it's really hard to tackle them once you're infected. So I'll talk about some of them superpowers and what they do then.
Okay, let's go.
So the first one that I find really interesting is a parasite called Schistosomes.
Right, say that one more time.
Schistosomes.
Schistosomes.
So, schistosomes cause a disease called Schistosomiasis. There's 3 main types of schistosomes. There's Shistosoma mansanii, hematobium, and japonicum. Shistosoma mansanii is the most prevalent one, but most of these cases, actually 90% of cases, are in Africa. So it's known as what's called a neglected tropical disease. Because we don't get them here, science doesn't give much care about them, so there's not much research done into them, hence they're neglected tropical diseases. So these are blood flukes. You're going to have to look up a picture to believe me. They look like the most alien creatures. The weird thing about schistosomes is most flatworms are what we call hermaphrodites, so they possess both male and female reproductive organs. The schistosomes aren't, they're dioecious, so they have male and female entities, or individuals. Once inside your heart vessels, the male and the female will wrap themselves around each other and live in copia. So it's a great love story, if you ask me. They live in copia, so they wrap themselves around each other and they'll produce hundreds of thousands of eggs throughout their lifetime. They live up to 40 years in people as well, which is quite creepy. But for the most part, you'll get some symptoms like fever, myalgia, which is sore muscles. For prolonged infections, if you have a really high burden, you can get some severe reactions to them. Mainly swollen livers, swollen intestines, swollen heart. They can cause obviously complications further down the line. But their superpower is incredible. We've heard of the Harry Potter invisibility cloak. The schistosomes have been doing that for hundreds of years. So the life cycle of a schistosome, you get infected through infected water. So when you're swimming, when you're dipping your feet in the water, they crawl through your feet. So they're able to bite through your feet into your blood. But as they bite through your feet, they actually coat themselves in your proteins. So once they're covered in your proteins, your immune system can't see it. It just sees it as yourself. So it goes, oh, there's me, and carries on. So it covers itself in your proteins, causing this invisibility cloak so that your immune system doesn't know it's there. These guys live in your blood vessels, which is where your white blood cells are. So it's obviously a very dangerous place for them to be. So that's what they do. They put on an invisibility cloak. The immune system never knows they're there. And off they go. They find their mate, they wrap around, and they live inside you.
So how big would this be? So
these are microscopic.
Thank goodness.
There are a few micrometers. You would need a microscope to see them. So you're not going to feel them. You might, however, feel the hundreds of thousands of eggs that they lay and burst out of you. But you'll be fine.
Right, so no swimming. Okay, no swimming.
Wear socks when you're swimming.
The Veruca socks.
The Veruca socks are great.
Be perfect. So how long have we known about these?
So parasites in general have been about for hundreds and hundreds of years. In fact, they actually, whenever they found some of the tombs of the Egyptians, they found liver fluke in embalming jars. So when they took out the organs of their mummies, they actually found liver flukes in some of these organs. So we know these parasites have been about for forever. That's what actually makes them so special and adapted, is because they have co-evolved with us. So any immune mechanism that we develop, they have a counteract to it, and they find their superpower to counteract it. So as long as humans, we've had parasites. As long as animals, we've had parasites. Okay.
Oh, creepy. So schistosomes.
Schistosomes.
Sorry, how do you spell that?
So it is SCHISTOSOME.
Okay.
Schistosomes.
Brilliant. So that's the first one.
That's the first one. So the second one then is Toxoplasma gondii.
Right, Toxoplasma gondii.
Toxoplasma gondii, so T. gondii. This one's really cool. So in parasitology, we have 2 classes. You've got the protozoans, which are single cell organisms, and you have the metazoans, which is your worms and your flatworms.
Right.
Toxoplasma gondii is a protozoan, so it's a single-celled organism. Really, really tiny entities, but what they're capable of is incredible for their size. So they can actually survive a lifetime in humans. So
our lifetime?
Our entire lifetime, we can have them. But us humans aren't the definitive host. We're not the end goal for the parasite, so they don't cause many symptoms with us. It's actually our cats that they want to get into. They can reproduce in our cats. So, some parasites have cool life cycles. They'll actually use what's known as an intermediate host. So a smaller host where they will develop in until they're ready to go into their main goal. So for the T. Gondi, that's going to be the mice. They know that cats are going to predate on mice, so they want to get into mice. And their superpower is mind control.
Mind control.
Mind control.
Mind control. Okay. So they want to control a cat's mind.
They want to control the mice's mind.
The mice mind.
Yep.
All right.
So what T. Gondi do is they'll get into the brain of the mice and they'll cause a few reactions in there and make the mice attracted to cats. So what actually happens is in cat's urine, there's a high concentration of certain proteins. The parasite makes the mouse attracted to that protein, so attracted to the cat's urine. It will find the cat, and as well, it causes a reaction in the brain that makes movement more sporadic. So they'll start making really sporadic movements, run around quicker, because that stimulates a cat's fight response. And all of these factors help influence the cat predating the mice so that it can complete its life cycle.
So you say they will live in us to get to the cat, so will it try and take over our minds?
Well, they have done studies on humans. We haven't found... So most humans are asymptomatic, so for any viewers at home that have a cat, you don't need to chuck it out, you will be fine. Most humans are asymptomatic. But a few studies have found a positive correlation in behaviour changes in humans. So what they found was women become a lot more fearless, a lot more adventurous, outgoing. So if you ever randomly decide you want to go skydiving, maybe check your cat. Men, on the other hand, become more suspicious and jealous. So they found that men will start to show high traits of jealousy and suspicion. They don't understand why, but
because it doesn't sound like that would get you a cat.
Exactly, but they've no idea why. But that's been the positive correlation in behaviour changes in humans. But as for nausea, vomiting, myalgia, the common parasite symptoms, no, you're in the clear.
So it's not a terrible thing in humans at all?
Well, it does cause some complications in pregnant women.
Right.
So it's one, whenever you're pregnant, they say try to stay away from cats. That's one of the reasons why, is toxoplasma. So, as with all animal husbandry, you always have to take care with the handling of animals, their business, their feeding, just always take care with animals and be cautious with your hygiene as well. That applies to most things.
Okay, so invisibility cloak, we've got mind control. Mind control of mice, that's, yeah, I like that.
It's cool, isn't it?
It's very cool.
They actually found as well that the mice have less ability to climb, and they believe that is because, obviously, mice being prey, they need to always scan their horizons, make sure there's no predators around, and they use vision for that. If a mouse can't climb or scale, it can't get a survey of its surroundings and therefore won't be aware of dangers around it. They really have this mastered.
That is really good.
Yeah, they really have this mastered. They know what they're at.
Yeah.
So T. Gondi is a cool one as well. Again, if you look them up, they're actually quite pretty under the microscope.
Okay.
They've got wee flagella, wee tails to get around. They're quite cute.
Right, so single-celled organisms.
Single-celled organisms as well. And then the other one I wanted to talk about is another protozoan. It's a trypanosome this time.
Okay.
So trypanosomes cause trypanosomiasis. It's another parasitic zoonotic infection. It's actually humans get infected from a kissing bug.
Okay, now I'm interested.
Now you're interested. So there's two types of trypanosomes. One, you'll get infected by a kissing bug, which bites your lip, hence the name. But the one I'm going to talk about is actually you get infected by a testy fly. So it's a long fly. It's got really glamorous wings, but you don't want to get bit by it.
Right.
So the trypanosomes, once you get infected, it goes into two phases. So the first phase is your acute phase. It's your normal symptoms, your fever, your sore muscles, headaches. The problem with that is commonly misdiagnosed as malaria because there's such
so similar.
Yeah, such similar symptoms is always misdiagnosed. The complications come in the second phase, so that is the meningoencephalitis stage. The problem is, once you're in this stage, there's no treatment. So it's all just palliative care from there on in. You'll get some horrific symptoms with that one, but the main one I want to talk about is once you're infected and it gets into your brain, it crosses that blood-brain barrier, you'll start to have central nervous system dysfunction. So what they found with a lot of patients was they were imbalanced, they were having sporadic movements, they weren't able to sleep. In some rural parts of Africa, people were believed to be possessed by the devil, so they tied them to trees to try and clear their spirits. They weren't able to walk, so a lot of people were holding their arms out, trying to get balance as they were walking.
I see where
Are
this
you
is
seeing
going.
where this is
I'm
going?
seeing where this is going.
So they believe that modern day zombies came from seeing patients infected with trypanosomes. So walking out with the arms, imbalanced, sleep deprived, they've got the baggy eyes, they're not looking too good. That's where we get our modern day zombies.
And of course, to spread this, it could be through mouth.
So there's no human to human contact, thankfully, unless you have a blood transfusion. So blood transfusion, organ transfusion. Thankfully, it's not in the mouth or the saliva, so you don't have any bite, sneeze, cough. None of that can spread it. It is just through the blood.
So if you get bit by these people, you're not going to get it.
No, you're not going to get it, thankfully. But that's what I find so interesting about pathology in general, is a lot of illnesses, a lot of pathology has stemmed into modern television, modern beliefs. So I know it's not a parasite, but rabies. So they think rabies, the virus, has caused the story of werewolves. So back in the day, we had no newspapers, no social media to spread information. It was all through stories. They believe that, and there's enough evidence to support this as well, back in prehistoric times when we were telling stories to spread information, people were told to beware of the vicious dog. And the way of telling that story was through the evolution of the werewolf.
Okay, yes.
So you can see where that one comes from.
I can see where that comes from, yeah.
Another one, some scientists believe that the idea of a vampire came from tuberculosis. So again, not a parasite.
Just
it's
TB.
Yeah, TB. So the main symptoms of TB, of course, you get that white flecks complexion. So you're really, really white. Your blood vessels are prominent then. So you've got your white face, but you see all the blood vessels. So you've got that scaling, the red veins we associate with vampires. So they think that the idea of a vampire came from looking at symptoms of patients with TB.
Okay. Yeah.
Another interesting one.
That is interesting. That is good.
But yeah, I like the idea of the rabies one. Beware of the vicious dog. You can see where that came from. So I always thought that one was quite interesting as well.
You get bit by a rabid dog.
Yeah, you get bit by the rabid dog. You turn into the rabid dog.
Oh yeah, that's great. Yeah.
So we've got them all of these stories, all of these superhuman powers, and we've parasites, we've biology and pathogens to think for them. The other one that a cool superpower is multiplication. So I always think of it, Loki's superpower when he makes multiple versions of himself and you don't know which one to attack. Parasites have been doing that since day one. They are prolific egg layers. In fact, there's one called ascaris. So ascaris is a roundworm. So they actually look like, the worms that you see out in your garden. They're typical worm-like features. But ascaris can infect an array of different species. Most of them you'll find are host-specific. So ascaris lumbricoides is the one that infects humans. Ascaris sum is the one that infects pigs. These parasites can lay up to 200,000 eggs per day.
200,000
per day.
So 1 million in 5 days.
Yep.
Wow.
The problem is as well, they can be up to 35 centimetres in length.
Wow.
So these guys are just in your intestines, laying up 20,000 eggs every day. You pass them out, you can reinfect yourself if you're
Yeah.
not good with the hygiene. You can infect family members as well. You can infect your animals. You know this. And it's all because of their multiplication power. There's actually an interesting's maybe not the right word, but there's a scary story of a parasitology student. So the message is, don't mess with a parasitology student.
Oh no.
So back in 1970 in Quebec, we had a parasitology student, and he was very messy. He wasn't doing his dishes, he wasn't cleaning them up after himself, and his housemates went, right, enough is enough, we're kicking you out of the house. And he thought, no, he said, let me cook you a dinner, let me make it up to you, I promise I'll be better from here. So he made them a lovely dinner. I actually think it was spaghetti bolognese. Made them a lovely dinner, and he sprinkled a few eggs on there as well. So 2 out of the 4 ended up in critical care in the hospital. He had given them ascaris eggs, so the one for the pigs. It had got into their intestines, their immune system attacked it. They went into autoimmune drive, and they ended up with really, really bad pneumonia. So don't mess with a parasitologist.
Okay, are you okay here? Do you want more tea? Or...
Yeah, so it's actually interesting that pneumonia is one of the symptoms of ascaris. They're parasites of the intestine, so you're probably thinking, well, how's the lungs getting into here? It's actually their life cycle. So a lot, as we were already discussing, a lot of parasites have an indirect life cycle, so they'll use an intermediate host. So a lot of them, it's flies, it's your mosquitoes, any biting insects to spread it in. Other ones will use smaller prey that we would eat. Ascaris, on the other hand, have a direct life cycle. So they only have the one host, and that's their definitive host. So what happens is you can accidentally ingest these eggs. Yeah. So normally it's by fecal oral transmission. So, you're not washing your hands after you do your business. You're eating contaminated food. That's how we're getting them. Once we eat the eggs, they hatch in our stomach, into our intestines. They'll break through your intestines into the blood vessels, where they'll get to the liver, to the heart. From the heart, then they get into the lungs. You will cough them up, so they'll come the whole way up your trachea. You'll cough them. Most people swallow their spit, so you swallow them back down again into the stomach, back into the intestines, and that's where they become adults. So they do a full cycle of your body.
Okay. Now, how prevalent are these?
So...
Right, you're thinking about all the ones we've discussed so far. I mean, how worried should we be? Apart from the fact we should all be washing our hands after
yes,
going
always
potty.
wash hands.
Yeah.
I always make this mistake because I'm so cooped up in parasites. I kind of forget that some people will fear them and not think they're cool like me. I can promise you will be fine. They've actually found a really, really significant drop in parasite infections, especially in the Western world, because we have such good hygiene now and we understand the importance of cooking food thoroughly, of washing hands, prepping food properly, washing your food, your fruit, your veg, all of that. All these precautions are really, really important. The unfortunate thing about parasitology is, unfortunately, it affects lower economically developed countries.
Which is why Africa is such a
exactly. So that's why we've termed them neglected tropical diseases. With the threat of climate change, we are seeing a range shift of some of these parasites, especially those that use intermediate insects. So a lot of the ones that use mosquitoes, because of climate change making northern equator warmer, we're finding that a lot of mosquitoes are making their way further up north, and with that they're bringing their parasites with them. So it is something we need to be vigilant about. We need to have the resources there to make sure that we screen for them. The problem is malaria is not a thing in Ireland, so we don't screen for it. I think it will take a while for malaria to get here, but we're already seeing south of France, Spain, Greece, we're finding a lot more parasitic infections becoming more and more prevalent as a result of climate change and these migrating species.
I have read before a few years ago that there is a specific species of mosquito that lives in underground in London.
Oh dear.
So
not all mosquitoes can carry.
yeah.
So it is weird. The parasite has obviously co-evolved with their intermediate host and their definitive host, so it means that they can only survive and thrive in them particular species. So thankfully, a lot of species will just kill the parasite to begin with, and it can't complete its life cycle. But the most important thing for people to remember is it is fine. Just stay vigilant. Make sure you know where your foods came from. Make sure you wash your fruit and veg. Make sure you cook your meat thoroughly. Or if you are having raw steak, make sure you know it's coming from a trusted place. And we can take these precautions to stop infection. As well, as we've already mentioned, parasites don't want to kill you. They want to live in association with you. They want to have a happy life where they use all your nutrients that you've made for them, and they don't want you to know that you're there. So a lot of parasitic infections, provided you have a low prevalence of them, are okay. But, back to the point I was making there of we're okay because we wash our hands, we wash our food, we cook our food properly, we have less parasitic infections. They've actually came up with a theory, it's called the hygiene hypothesis. So the theory goes that because we are so good at preventing disease now, we have proper healthcare, we've treatments, we have sterilisation methods, we are becoming less and less infected with parasites, with bacteria, with fungus. The problem is then, with that, there's now been a correlation between less infections and more autoimmunity, so more allergies. Because our immune systems are always prepped to fight something, but there's nothing to fight, they're finding that that's where we're getting a lot more allergies in the Western world. So hay fever, for example, is on the rise. And they actually think a lot of that is to do with the fact that we aren't getting infected with as many parasites compared to those in less economically developed countries who are always fighting something. You're finding less cases of allergies there.
Okay.
Which is quite interesting.
That is quite, because there is that boom when you think about the amount of people I knew 20 years ago who were celiac compared to now.
Definitely.
And
it's interesting that you mentioned celiac. I don't know if many people are ready for the jump yet, but they're looking to see if we can use parasites to treat a lot of autoimmune diseases, particularly those like celiac, Crohn's disease, IBS, IBD, all of those. So as we were talking about there, parasites try and evade the immune system, and a way they do that is by releasing anti-inflammatories. So it's basically a signal to tell the immune system, just calm down, it's okay, we're okay. So they have done trials where they have fed worms. It's one called Trichurasuus. So it's a pig worm. They have fed Trichurasuus eggs to Crohn's patients. The Trichurasuus gets into the body because it's evolved for pigs. It doesn't have that risk of them, being able to reproduce and carry on infection. The worm will get into the patient. It will release all these chemicals to say, just relax, immune system, it's okay. And obviously that's what Crohn's is. It's an inflammatory response in the gut. So if you're able to have something that's calming that inflammatory down, they found a 74% relapse in patients of Crohn's disease. So that's a really, really significant, really promising result that we could actually, with the parasites exploiting us, we can now exploit the parasites.
Always good.
Always a good plan. Always a good plan. So I don't know how you feel. I think in some cases they were feeding the patients about 200,000 eggs, and now they serve it in a wee shot glass. Down it goes.
Oh.
But if you look at the results, if you were suffering from Crohn's or IBS, of course you're going to take these treatments. It's looking really, really promising.
Well, I remember when they started doing what was it, grubs to clean out wounds.
The maggot therapy.
That works really well.
It's an incredible therapy.
As long as you get over that.
Exactly, this is it. We've been using these treatments since the beginning. It's only that we've become really good at finding therapeutic drugs that, we don't look to these treatments. But maggot therapy is so promising. So if you have a cut, a burn, something that's infected, these maggots will only eat the necrotic skin, so only the dead skin. clear it, it will leave the soft skin alone. So they also as well, they'll put a mesh on, so it's not direct contact maggot to skin.
Oh, right.
But so it's a wee bit more hygienic as well. But definitely the results from maggot therapy, if you look at the results, put all the grossness aside, go and use that treatment. It's really, really good. It stops the risk of antibiotic resistance. That's a huge thing for parasitology as well. Anthelmintics, so anti-worm drugs. There's a huge, huge rise in resistance, especially because of modern agriculture. We've so many pests, we've so many diseases. Farmers, and you can't blame them. They're obviously trying to make a profit, so our food's being smothered in these crops. Our sheep, our cattle are all being injected with all the anthelmintics, all the treatments. So resistance is prevalent, of course it is. So if we can try and find methods that don't use drugs, but instead exploit different life cycles, exploit different characteristics of the worm itself instead of having to use drugs, we could maybe help this crisis that we're in as well. So, there's so much research in parasitology. It's such, it's a growing sector. Day by day, we're learning more and more about it. And that's what I find really interesting about it as well.
Is it like many other... there's only so many insects that we've discovered, and there's so many more. Is it exactly the same with parasites?
Yeah, exactly. Insects are the biggest class of animals out there. We think we know them all, and we don't. There's millions and millions of undiscovered insects out there. It's the same with parasites. We're learning so much about parasites every day, and only with improving methodologies are we able to find out more information about them. So it's a big bad world out there, but we'll get it.
Anya, listen, thank you very much. That is really fascinating.
It's a very crash course on parasites. I could talk for another hour about them, to be honest.
That. And if anybody does want Anya to come along and speak at an after dinner event, I'm sure that would be
any excuse to talk with parasites, I'll be there.
But that is fascinating. Listen, thank you very much for coming to talk to us about it. I know you love to talk about it in the break room at work while people are trying to eat, but it's nice to give you a bit of space here away from the food. But also, all the best with your doctorate.
Thank
that
you.
You're starting. When are you starting it?
Starting in October.
In October. I'm going to put notes on the various platforms of which of these creatures we talked about. And thank you very much. Hopefully people got a lot out of that. I know I did. I found that really fascinating.
That was good.
Which is the reason you're here. I do find people fascinating. But thank you very much.
Thank you for having me.
Love her, love Uncle Ben. They are the best. Just ask the whole group of kids, hey, do y'all want to go to the science exhibit like it's the most normal thing in the world? I felt this bite on my hand. It was a weird looking spider, like it was glowing. This is amazing. So before it fades, I've got to figure out something I can do. Okay, world. Better hang on to your hat. Here comes the Spider-Man. The Spider Diaries, a John Reed's Comics production. Look for the Spider Diaries on your favorite podcatcher or at johnreedscomics.com. And there's no H in John.
And that's the end of the episode. Thank you to Anya for coming along. It's been fantastic talking to her. She really is very enthusiastic about this. If you would like to say about your love of parasites, you can contact us here at Marksmess Podcast by email at mymarksmess@gmail.com. We do have the Twitter feed that I sometimes look at, on Instagram on the Marksmess label, and on, of course, Facebook at Marksmess Podcasts. Thanks to Josh Woodward of joshwoodward.com for the title music. And hopefully we'll be back not too long in the future, maybe even with the girls, talking about something even more geeky and something even more fun with them. So hopefully we'll hear from us soon, and bye!